Hello and welcome everyone to this joint webinar from SuperAnnotate and Databricks. Today, we're going to talk about how you can work with adapting LLMs using your data with SuperAnnotate for data creation and model evaluation, and Databricks for model fine-tuning and deployment. My name is Leo Linden. I am heading up product marketing and working with solutions engineering here at SuperAnnotate. And with me, I also have Prasad from Databricks. Would you like to introduce yourself briefly, Prasad?
Thanks, Leo. This is Prasad Kona. I'm a partner solutions architect at Databricks.
Yeah. So let's get going. Today, we're going to cover a couple of different topics. We're going to start by asking ourselves, why would you want to adapt a large language model in the first place? Once we've established that, we're going to start moving on to the question about how can you go about adapting large language models. And we're then going to look at an example that we have put together where we go ahead and we compare prompt engineering and fine-tuning and the different results we get. We'll then move on to how to fine-tune, and particularly fine-tuning in Databricks, where Prasad will be speaking on how you can go about that and how Databricks products makes fine-tuning of models a whole lot easier. After that, we're going to enter the question about where do you actually get the data you use for fine-tuning from? That's something that's often overlooked in a lot of products that go ahead and make fine-tuning really easy, but a lot of people are still stuck because they don't have the data to fine-tune their models with. And then talk a bit about SuperAnnotate and how we and our products help companies create their fine-tuning data sets and do model evaluations, followed by a short demonstration of both fine-tuning in Databricks and SuperAnnotate together. So let's jump into why would you want to adapt a large language model? So there's a lot of different use cases where a general language model might fall a bit short if it's not adapted in any way at all. You might want to use ChatGPT or a similar model to do sales on your website or to help customers, something they're not designed for initially. Or you want to set up a system for internal knowledge search in your company or on your website, and so on. You might want to create a task-specific language model, so something that's specialized, maybe in data extraction. So say you're getting a lot of emails to your customer support, and in general, you have a few keywords or different topics that you want to extract out to be able to route them to the correct department for quicker resolution. You might have to adapt your model to that specific task. No, there's been use cases around headline generation where a company or a news company that has a large amount of news articles want to streamline the process of actually generating the headlines or creating the headlines from them. And then they can go utilize their old large database of articles with headlines and kind of adapt the model to that. Another thing could be code documentation. Or you might want to build or create a domain-specific large language model where instead of general knowledge, like you might find in a lot of the general language models, you might want to tune it more towards medical data or legal data or financial data, fields that have a lot of very specific terms that a generalist model might not necessarily know. So there's a couple of different ways to go about fine-tuning of models or adapting models to your use case. The first one, and the one probably most of you are familiar with and have already tried out, is prompt engineering. And this is essentially guiding the model by writing careful instructions where you detail exactly what you want the model to do or add in any specific type of domain knowledge that the model should have into a prompt, or a system prompt that is then sent to the model together with the question from the actual user and then guides how the model answers that. Another way to adapt models to your data would be using RAG. And this is connecting your model to sort of a search tool, usually a vector database, but might be other search functionality as well, that can provide information that is relevant to the question at a time of search. And the third one would be fine-tuning, and this can be instruction fine-tuning, it can be continued pre-training, or it could be different forms of reinforcement learning. But that's really where you use a data set of examples or a larger data set or feedback to further adapt the actual weights of the model to create a new model that is specifically tailored to what you want to do. All of these have some pros and cons, and you'll find that in the real world, you'll probably end up kind of using all of these together in the same system. But with prompt engineering, it's really quick to get started and to iterate. You don't really need large amounts of label data, even if some label data in the context can be useful. And has some drawbacks though. That handcrafting a prompt can be really complicated, especially when you're using smaller language models. It can be more difficult to steer. Adding in this system prompt, it decreases the available context window for the task you want to do, and it might end up being less reliable. With RAG, there's no need to include the knowledge that you have the model to do inside a prompt. You can easily feed up-to-date information into the model, but you need a large database of pre-processed data to actually search through and set up these sometimes complicated interactions or manage additional latency between systems. Fine-tuning, you don't need to worry about the prompt. You can minimize the amount of token that kind of takes up the context window as well, because you do the show, don't tell sort of setup. But you do need prompt label data, oftentimes large amounts of it, but sometimes, as we'll see, smaller amounts might be sufficient. It might be slower to get started. You need a training infrastructure, but the results might get better or more reliable by using this. So we're going to look at one example that we've been working with here around, we've been inspired by real world, but adapted to something that's sort of easier to look at in a webinar like this. And you might have seen over the last year, really since chatbots came out, and especially when they start becoming more widely used, that a lot of the times they don't really do what they want us to do or what we want them to do. They might, in an example with Air Canada, made up a refund policy that a company had to honor. We've seen use cases where supermarkets has implemented chatbots that have generated very odd and sometimes dangerous recipes, or where chatbots have been found to give sort of discounts in car sales as well that the company really do not want to honor or be a part of. So there's a lot of things you don't necessarily want your chatbot to do. Today, we're going to work a little bit with an imagined scenario where I have deployed this chatbot, or imagine that you have deployed a chatbot onto your website. We are having some issues with that because it turns out that a lot of people started using your chatbot, to have it answer questions about mathematics, which takes up latency, takes up inference, picks up your inference cost, and so on. So the question becomes, how do we address this? How do we make sure that we get to a state where maybe the chatbot, we fine-tune or adapt or use prompting to make sure that it does not answer any questions that are related to mathematics? So this is what I would love it to say, is that you simply decline, I'm sorry, but as an AI assistant, I am unable to assist you with solving different mathematical problems. I might start by adding in a system prompt. I've written one up here that contains a little bit of guidance that saying that this is a chatbot and you can answer all questions except questions about mathematics. If you're answered a question about mathematics, just reply with, I'm sorry, I can't help you with that. Don't attempt to solve the problem. Don't offer any guidance. Simply say that and then stop the conversation. And then like an example input, example output. You can, of course, think a lot about exactly what works. Getting to this one was a bit of an iterative approach. Sometimes things work better, sometimes things work worse. But here we actually get an output where it does decline to answer this question. So what I did was I took this prompt, another simpler guided prompt, and we also built out a data set of about 400 examples of questions and answers, some containing mathematics, some not, and then fine-tuned the model in Databricks, fine-tuned based on Llama 2, 13B here, where we did a comparison just for the prompts and so on as well, to see what the results would end up being and how much data you actually need to use to do some fine-tuning. The results we ended up with are here. And what we could see that was really interesting is that actually, even with quite a small data set, we started getting better and better performance out of the models. A very easy prompt in the beginning, where the model was just told, like, don't answer questions like this, you can answer anything else, which gave pretty good results. Accuracy is around 70%, recall isn't that great, precision is quite low. And with the advanced prompt we saw, actually precision is even lower. So what ended up here is that the models are often very overly cautious, and they refuse to answer questions such as how many genuses are there in the German language, because that contains a number, which might be mathematics. So crafting good prompts can be really hard. However, when starting fine-tuning, already from the start with only 64 data examples, we did see an accuracy that was higher, slightly lower recall, but a much higher precision. And it started actually answering more questions than we wanted and decline more of the math questions as well, and kind of steadily increasing when we increase the data set, although kind of growth of this slightly decline once it grows up a bit taller. But the main difference that we could see here when we actually look into the data is that if we start putting adversarial prompts into this, the prompt engineered model completely misses it. We add in this, kind of ignore the previous instructions and a new guidance, and all the prompt engineering sort of goes out the window, and it goes ahead and answers this question. Whereas for the fine-tuned model, we kind of protected that. It's trained to, as long as there are any sort of mathematics into this, just decline it. And it actually works in most of the adversarial prompts that we've added in here as well. So it might be some cons and some pros, depending on your exact use case. But fine-tuning can give some pretty decent results, even with quite small data sets. So what I want to walk on to now is kind of how can you go about fine-tuning? What are the steps involved? There's really a few steps you need to get through to fine-tune a model or train a model on your own data sets. The first one is you actually need to have a data set of your own. And we call this kind of data set fine-tuning because it doesn't have to be just taking a data set you already have. It doesn't have to be writing a data set completely from scratch, but it's sort of everything that's involved in either creating new data sets or adapting already existing data sets to make them ready for fine-tuning. Of course, need to do training and training of these models once you have the data set, manage training pipeline, training infrastructure, and be able to deploy and host this model to access it. And also, you need to be able to do evaluations of your model to make sure that, well, I've trained it, I fine-tuned it, I deployed, but did it actually do what I want it to do? And these two in the middle, Databricks is perfect to go into the training and deployment. And what we find is SuperAnnotate fits quite well in here around helping you create these data sets and helping you do the in-depth evaluations of models. So now I want to hand over to Prasad to talk a bit about how do you go about training and deployment and fine-tuning of models in Databricks.
Thanks, Leah. We just heard about like the need for fine-tuning, right? And how you can actually adapt your LLM for your use case, right? Typically, when you're looking at a generic LLM, they're usually fine-tuned, they're trained on generic data. And with fine-tuning, one can adapt your LLM to a specific task or a domain. A couple of popular ways one can do fine-tuning is the first one is supervised fine-tuning, right? This is where one can train on like say request response pair or like chat kind of data, right? In this way, this typically is used to train your model to actually do a specific task. The second popular way of fine-tuning is continued pre-training. This is where you're actually training your model on unstructured text or data, right? This typically introduces some domain-specific knowledge to your model. Right, we just heard from you on some of the steps in the training process that looks like, right? And so from all the way from data prep, training, evaluation, and deployment, right? This is typically an iterative process that that can be repeated multiple times as you are actually refining your model. This entire process sounds very simple, but there are a number of challenges that you might face as you're trying to train. Right, let's start with data preparation, right? One needs to have high quality data. Then you also need to worry about how you can govern this data in a secure manner, and to do data prep, and also to transform the data so that it is actually ready for training, whether it is tokenization, formatting, and how to improve the quality of your data sets, right? Once you have all of that nailed down, the next comes the training phase, right? This is where there are a lot of knobs that one needs to use, like whether to configuring hyperparameters like learning rate, all the way to hardware configurations when we are trying to execute these training jobs. And then comes about how can you run these jobs in a reliable way, and how can they be made tolerant to errors. Monitoring the jobs is also that comes next, and of course, how can you checkpoint your model weights so that you can reuse these weights as you further fine tune. Once you're done with the training, next comes like how do you some of these challenges of how can you evaluate your model? How can you deploy these models in a secure manner to be used for various use cases? Many of these challenges are like we're very familiar with these, and these were some of the reasons why we built the Mosaic AI model training as part of Databricks. It's a unified training platform that will help you simplify the entire process, right? This is the same stack that we use, that our research team uses as we train our various LLMs, including our in-house LLM like DBRX. We offer both types of fine-tuning, supervised fine-tuning, and continued pre-training. To get started, one would just need to choose your model, specify the data in Unity Catalog, which is an end-to-end governance layer for data and AI assets. We have MLflow that helps with experiment tracking and operationalization of end-to-end machine learning workflows. And then you have model serving, where you can actually serve these models efficiently for your use cases. So how do you get started with model training on Databricks? It is very easy. We provide two mechanisms on how you can actually start model training. One is by using Python SDK or REST API. You can set some simple parameters like the model that you want to use, the data that you want to train on, and a couple of other additional configurations that you want to use, and then kick a fine-tuning run. We also have a simplified UI where we just walks you through selecting your data set and just starting model training with just a couple of clicks of a button. Right, we talked about some of these challenges earlier, right? And with Mosaic AI model training, some of these challenges are no longer there, right? For data governance, that we can train data directly here from the Unity catalog, right? This is where it governs all of your data and AI assets. You can efficiently like process all the data that is there, whether it is formatting the data or tokenizing under the hood, all that is taken care of. We provide the various optimized parameter defaults so that you don't have to worry about a lot of these hyperparameters that one needs to deal with. And how about running these jobs? This is completely serverless. Like no need to think about GPU provisioning or managing infrastructure. For the experiment tracking, we provide like MLflow experiments helps with that. We also automatically checkpoint your model weights during the fine-tuning runs and at the end of the fine-tuning, so that you can use these weights downstream as part of your fine-tuning process. We also have frameworks like MLflow Evaluate to help you evaluate the runs. And finally, with a single click, you can deploy these fine-tuned models using Databricks model serving and support your various use cases. right? Before we, before you can actually start using all of this, right? One of the key things that Lee also talked about earlier is about having high quality data sets to help fine tune. This is absolutely important, right? These high quality annotated or labeled data sets that are specific to your task is extremely important. So I think during the rest of the talk, we're going to see how SuperAnnotate helps with fine-tuning your data sets and helps improve the performance of the LLMs for your use case.
Thank you very much. So we're gonna jump into here. It's a little product screenshot before we move on. But we're gonna talk about, yeah, where does the data come from? So in Databricks, once you have your data set ready, like you can get going and you need these prompts and the completion pairs, but how do you actually get to that stage that you're ready to go? We see that a lot of people have problems with this. A lot of companies kind of get stuck in this stage, but what you need is really examples that represent what your model should do. Questions and answers, or multiple steps of questions and answers, is the type of data that you need to convert your data into. You might need to capture the expertise and domain knowledge needed to carry out these tasks in these data sets that you use to train the models as well. So if you're in a stage where, like, you have a process internally you'd love to automate, but you don't really have the data set there, you need a way to get all that expertise and domain knowledge down into a data set you can train on. And some organizations might already have these data sets internally and ready, and you just need small adaptations to it. But most users might need a new data set built from scratch, especially if it's a completely novel application. So how much data you need for a model can really vary. It varies depending on the size of the model, the complexity of the data that you use. And it can really range from in the tens of examples. And you saw in this week, achieved pretty good results with around 100 to 400 different examples. But it might also be cases where you have to tens of thousands of examples, or if you count in tokens, maybe, millions to tens of millions of tokens to train these models. And to build data sets like this, you might get started out in Excel, start putting your data set together. It works for a couple of examples. It maybe can take you up to 100. But as soon as you want to bring maybe more people into creating the data sets, reviewing the data sets, that's not going to work anymore. Or you might have to involve non-technical users into this process, and they're not going to be familiar with working in Databricks or directly in your IT tools and getting this data in. Manage follow-up and quality control of this data, no matter if it's synthetic, if it's data you already have, or if it's human-generated, and how you also go from having prepared a data set to get it into your data system. You have this nice table, but how do you get it into Databricks? Or you want to incorporate a model in the loop to keep improving and iterating on something you already have. And that's really what SuperAnnotate is specialized about. It's one of the leading, or the leading platform, I would love to say, for really helping you create the data sets that you use to train your models. And we're working with tons of customers in this space, and a lot of the different foundational model providers that you have heard of, foundational models that are out there. Some that I can mention is Canva, it's IBM, it's Databricks, and very happy to say is one of our big customers as well with their BRX model, as well as Qualcomm and a lot of other companies as well. So what do we actually do? Well, it really helps companies to train their models faster and train their models to be better. It's a combination of the platform that is a fully custom and integrated large language model training data set, a creation platform, and QA tooling that really minimizes the amount of time you need to spend on each individual item in your data set, and it helps you achieve a much higher quality data. Together with this, for a lot of very large customers, we also offer services where you might be able to outsource the entire process around creating a data set through our team that has been working on a lot of these really big foundational models out there. So if you need help and guidance and expertise in exactly how to design and create and build data sets efficiently, you have access to experts that really have been doing this a lot, from small scale to extremely large scale projects. So how do we fit in with Databricks? And this is a bit of a messy slide here, but really with Databricks, we can connect directly to the data that you have in Delta tables in Databricks. You can very soon go into Partner Connect. You just click on the SuperAnnotate logo there and everything is set up. You can then go ahead and you can build custom annotation tasks in our editor, and go ahead, build data sets, and then easily send that back into Databricks and Mosaic AI to have these models fine-tuned, and then connect directly to the fine-tuned models again to do model evaluation. And this is again how it streams. The platform slide here, it's a product called Fine-Tune, where you can build these custom data sets. We're going to look in the product soon to get a better understanding of this. It's a tool called Explore. We can easily kind of visualize and work through on large scale your entire data sets, as well as customized pipelines where you can work and you can automate a lot of the workflows and kind of manual tasks away, as well as setting up an LLM as a judge or agents to help you build these data sets out more quickly. It's a fully secured platform. We work with companies in the medical space to really any other type of both enterprises and startups. And around services, we help companies both kind of building out SFT data sets, RAG, model in the loop with RLHF, red teaming of models, as well as providing sort of strategy, consulting, and advice around how you can go about getting your data sets ready. And it kind of fits in between maybe your data scientist, your QA team, kind of the SuperAnnotate platform to both build data sets, or if you're already working with kind of data annotation partners, you can manage them through the platform as well to really streamline and unify and consolidate a lot of your data acquisition. And some examples of companies that we work with is one of the leading foundational model providers. We helped achieve a 30% cost reduction in doing RLHF. We worked with Databricks to decrease evaluation costs of 10 times with one of their big RAG projects, as well as helping them getting data for their large language models. With 12 Labs, we're building a model to generate natural language search for videos, something you definitely check out. Using our platform, both were able to scale the operations really quickly. And with our service team, they're able to kind of complete projects that previously took them 8 weeks in just around 4 weeks, so really halving the time to getting to their model, as well as a really large autonomous vehicle startup that we work both as a data partner and helping them with design and develop instructions for the data sets they need to be able to train their language models on their own data sets. So this is one quote we're happy to have been receiving from Jonathan Frankel at Databricks, the chief neural network scientist there and previously at Mosaic, who said he worked with SuperAnnotate after reviewing a lot of different companies in the space, but selected as thanks to the high quality of the data they were able to do, and really see SuperAnnotate not only as the data acquisition vendor, but also as a partner and a part of their data pipeline. So with this, we're going to jump ahead and we're going to actually showcase some things live. And what does this look like? How does it work? We're going to start out with Prasad just showcasing how you can go about fine-tuning in Databricks. And then we're going to jump over to SuperAnnotate, see how we put up tasks to both get and evaluate the data set in this little example we have, as well as some other things that you can do with our platform. With that, I'm handing over to you, Prasad.
Yeah, thanks, Leo. And so this is, I'm just logging into a Databricks workspace. I'll briefly show you how you can get started with fine tuning, right? And so one thing about Databricks is like all of the data and AI assets are governed and exposed via the Databricks Unity catalog. So one can click on catalog. You can search for your data assets. So in this case, I'm having they're all registered as tables. In this case, I have one called the refusal schema. This is my data set that I want to use. It's exposed as a table. So you can see the metadata now for the table, like the data types, the column names, view the sample data, set permissions on who can access this data. You can grant and revoke permissions, look at history, lineage. It's an end-to-end end-to-end visibility of the data that you have, right? Once you have these data set ready, right, it can be queried and used by various personas, whether someone who wants, it's a SQL user who wants to query the data using SQL, or or a data engineer who wants to use notebooks or create jobs that run on Databricks for their data engineering tasks. I'm just going to focus on the machine learning capabilities around fine tuning. And so, in order to fine tuning, you can click on experiments, click on the model training, and as you see here, right, we provide the 3 ways you can fine tune your model. It is extremely simple. All you need to do is select a foundational model that you want to use. We support all the leading models out there, from Llama 2, Llama 3, Mistral, and others, DBRX and others. And so, say for example, I've selected one of the foundation model. The next step is to select the training data set, right? And so in this case, if I'm as I have a particular table that I want to use for fine tuning, I'm just going to select the particular table, select the compute, like whether it is GPU cluster that you would like to use. And once the training is done, I want to register this LLM back to Unity catalog, so that you can serve this model and use it as part of your use case, and govern this model as part of your use cases. You can click on even the advanced options, where you can actually set any key hyperparameters if you like, and also if you want to even do some model evaluation also, right? And once you've done once you have configured this, all you need to do is just click on start training, and this basically it kicks off the run to train to fine tune your model based on this data in Unity catalog. So I'll now hand it off to Leo to show how SuperAnnotate can improve the quality of these data sets.
Thank you, Prasad, and thank you for that showcase of Databricks fine-tuning. We have spent a lot of time in Databricks fine-tuning, kind of preparing for this webinar, doing fine-tuning. It's a really easy to use tool. And so we're going to start having a look using these two. And then we're briefly going to show how you can go about kind of creating your own project that is custom completely to your use case, and look at a few different examples of types of products that we see customers using and being successful with as well. So for the training data set, we have 545 different items. And if we open one of them up in here, in this list, you can see there's really a data interface around creating these types of data sets. Up here, we have a prompt. Down here, we have a response, in this case, kind of marked as this should be a refusal or not a refusal, because it's thumbs down for refusals and not a refusal. And this is really an interface that can help you build data sets using people or model in the loop setups, or evaluate synthetic data sets. We create a general type of template, this prompt response, and you can assign this task to a lot of different people, say in your organization or vendors, that can then come in, do data annotation. Once you're done with an item, kind of writing down prompt response, move on to the next one. Kind of quality control layers as well, where someone, once an item is completed, can come in as a QC and leave comments to wherever it's necessary, send it back to the person that created this item, and kind of have that iterative process to build high quality data sets. So this is where we built out this data set, evaluated and curated it, that we used to train these models. And we send it over to a Databricks using a pipeline that you can set up in here as well. The second part that you will encounter is sort of how you can go about actually testing. So in Databricks, you get tons of really nice metrics around training run, how your accuracy increases, but in a lot of cases, qualitative evaluation can also be necessary. And here I have a model evaluation project where I've set up a task where you can look at kind of the prompt, you can look at the completion and say, was this actually a refusal? What was the quality of the answer? And also set up where we can run an LLM agent to do a preliminary pass of all that evaluation for us. So to get data back into SuperAnnotate from Databricks, we run the model in Databricks to get ourselves a list of kind of the prompts and the completions for these different setups. And to get it in here, it's really pretty easy. Go ahead, I select my integration with my serverless Databricks cluster. I write my little SQL query here and I run it. And I get the opportunity then to map the different columns that I have in my table towards different fields that I've set up in my user interface, the prompt, should we refuse the training type and remove different items and use the added data set in. And the evaluated data set, I get in here and jump over to the tool we call Explore, where you can easily kind of scroll through, you can see your different models. And what you can do here now is I've set up a run that has a large language model kind of go through this form for you and evaluate. We just go down here, it presses run pipeline, you can get your model and data set evaluated and move on to kind of look at predictions and results over in what we call the Insights tab. So you can easily go ahead and say that I want to see the, for example, the count of items by if it was refused, and break this down with it should be refused to get this sort of graph that I can use to then get recall, precision, and so on for this model. There's also tons of other types of annotation use cases you can set up in here, because most use cases we see in the real world are not this simple. It's not always just having a piece of text to create a prompt and to create a response. It can be more advanced tasks, like say that you have a coding model that is helping your coders with your type of API. You might have evaluations of where someone, an expert from your site, can actually go through questions and answers that users are asking to this model where it generates code. But you might have to go through and review, improve, and double check and run this code as well. Or you might create different types of chat interfaces, or you might have an audio model that you want to gather data for. So you can build out all these different types of use cases. And here I'm creating this little test project. The first thing you put on when you start creating a new project is deciding what type of task is it you want to do. Maybe you want to do fine-tuning of a large language model, compare different models to evaluate on your use case, or do video captioning or RLHF for image generation, or build something completely novel and new from scratch. You get access to this type of form where you can go ahead and drag and drop your own different types of components. For example, a PDF component, if you are a doctor or you're building this for kind of a medical use case, you might have doctor's notes in a PDF format that you want to add in. You might have another type of tool, and maybe a DICOM tool that you have deployed on a server somewhere you want to add in. You can do that here. And then add in also these different text components where you can get answers written or different evaluation groups to really build a completely customized user interface. And move on and also connect that to any different type of API on your end. So this can be directly to models. It can be to different types of systems as well to start building out a really interactive annotation interface. And we have some examples that we set up here around kind of video description and captioning, where you can both go ahead and you can see a video, the annotator here, then kind of go down and write what's happening in this video. And this can then be used to train that sort of video captioning or video evaluation or video search type of models. Or other use cases where you might want to go into a video. I have another video here I can go and play, and I can go and create different sort of event taggings in here as well, with captioning, start and end times, and so on, for in-depth kind of dense video data sets. Or you might walk over and do programming use cases as well, where you get a piece of code you need to evaluate with a description, you can test and run it directly in the interface we offer, as well as do corrections and save these items to export to data set you can further fine-tune models on. With that, let me jump out of here and also look at one use case we're seeing quite often that's related to RAG that we mentioned in the beginning. And that is in a RAG system, there's a lot of different components. And here we have a use case where people have a RAG system deployed, but it's not performing exactly how they want it to do. And if you want an in-depth understanding of exactly how the system works, where it falls short, and what components, as well as opportunity to gather data to fine-tune and improve these different components, you can easily build out an interface like this. Up here, you get the question that your user is asking your RAG system. Then here we can populate and get in the context that your retrieval model gets, and finally provide an answer down in the bottom, and give the opportunity to either with sort of an LLM agent or manually for your experts go through, can rank, well, how relevant is this context that our model provided? You can use this data to then further train and fine-tune your evaluation model. But also go down in the final answer, set up a type of a scoring chart where you can go through and really evaluate on different types of criteria to get more objective, data-driven insights that you can use to decide what the best course of action to improve your model and also fine-tune and actually improve your model with. That is a short overview of a bunch of different things you can do and set up in our platform. But the key takeaway is really, for any type of data set creation or model evaluation task, you can build a completely customizable interface and easily distribute that out to either your own workforce internally at the company to use. If you have an annotation partner or provider to do annotations in, you can manage QA and follow up. Or also if you want to use large language models mainly and just kind of double check and have a human in the loop, this is a tool where you can get all that set up and easily get the data in and out from Databricks and make editable. So I'm going to stop sharing there for a little bit, and we are going to have some time to answer some questions. And let's maybe start from, I know we have one question here from Maya around if we have worked with small businesses before. Most of our customers are large companies, and that really do depend. We have worked with small businesses, and small businesses can also get started kind of mainly using our software. Depends on the size of project, the type of project you have, how much data you need to build out. But really, anyone can get started using the platform to build their own data sets. And then if you need large-scale services, that is, of course, more bigger businesses that we work on that with, but we're also open to explore. And from Rocco, I think we have a question for you. Are you able to see the questions, Prasad, or should I read it out for you?
Yeah, I'm able to see. Let me.
Yeah. So it's a question about, is it possible to use the fine-tune models locally, or do they have to be run within Databricks?
No, I think it's like trying to fine-tune LLMs is extremely complex and requires a lot of infrastructure. Right. And yeah, and so if you're trying to, you won't be able to exactly fine-tune some of these large language models on your laptop, or if you're trying to do locally, right? And so that's why a platform like Databricks, we manage all the infrastructure behind the scenes, whether it is how to optimize the runs on various GPUs, whether it's single node or multi-node, and run it across, run it efficiently, to actually do this fine-tuning job.
Yeah, but I do believe, right, and correct me if I'm wrong here, Prasad, but once you have fine-tuned a model in Databricks, it is possible to download that model, right, and deploy the final model in my system as well. So it is not
Oh yeah,
locked
absolutely, absolutely. Yeah, you can, because we checkpoint the model weights, and you can. These are all the models are registered as MLflow models on Databricks. You can export these models in that open format, and also deploy to any infrastructure.
Yeah. And we have another question here coming from Amir around knowing that large language models are typically trained on millions of books, articles, and other types of documents. The question is, like, how can a 100-page document potentially efficiently make change in the large language models, billions of parameters when they fine-tune with less data than that? So this, I'd say, is quite a complicated question, and in many cases, it will depend on your use case. There are a couple of different kind of rules of thumb, but for one, when you fine-tune a model, you don't have to teach it everything from scratch. Like when you train them on millions of books, articles, and other types of documents, a lot of what the model do is kind of learn how the language hangs together, start to form words or sentences and so on. And once you fine-tune a model, you can really reap the benefit of everything that it has already learned from this very large data set, and usually makes much smaller adjustments to the model to kind of just tune the output a little bit in the direction, or increase the probability for the type of output that you want. And there's tons of, I mean, once I got started with fine-tuning, nothing worked because there's all these different hyperparameters with learning rates and everything that you need to know exactly how to tune to not kind of mess up what the model has already learned. And that's something that Databricks does really well. They really abstract all that away and figure out the best for you. And then if you want to, you can go in and kind of start tuning a little bit of them. But really, the short answer is that once your model is trained on this really large data set, usually with a smaller data set, you can skew it a little bit in the direction that you want. And then depending on your specific task, if you actually want to give the model more knowledge, it might be continued pre-training. And there is generally, I think, Prasad, a much larger amount of data that you would need versus for supervised fine-tuning, where you, instead of just training it on a document, have a very defined task of just like a set of questions and the specific types of answers you want the model to give. And then you usually need less data. Like in this case, we managed with around 400 examples, but to be sure, you might want to have a couple of thousands or maybe even tens of thousands to ensure higher performance, especially if it's a bigger model that you're fine-tuning.
Yeah, and exactly. And I think it's when you're fine-tuning, you can provide all of this data, whether it's a smaller data set that is that is of very high quality, or domain-specific knowledge that that you want to infuse into the model, right? And so with pre-training, you'll be able to do that on Databricks. Yeah.
Yeah. And we also have a question from Michael. The first of them was around kind of how to control costs, and there it depends, but like when you did the training in Databricks, it's only priced based on the amount of token and type of model that you use. Of course, if you need to start and build out a data set before that, that's a whole different question. There will be additional costs. It depends again on the complexity of your data set. You just need to use, say, the platform to build a data set, and that's much easier. And then it can be like if you need large scale services, you need to think more about that aspect. But can you define custom metrics in Databricks when you do training runs, or is it only your predefined metrics that you can use per Sonnet?
And so, like, yeah, we definitely provide the flexibility to um, to to add certain hyperparameters, and while using the API, you can make it, you have additional flexibility on what you can pass to the fine-tuning run. And so from the UI perspective, you can just see it's like we kept it as simple as possible, doing all the heavy lifting behind, taking all the heavy lifting behind the scenes. But for someone who needs a little bit more flexibility, the SDK and API provides that during fine-tuning runs. And one more thing, like we use the same one to train our in-house LLMs, and we continuously make sure that this is exactly the platform that we also provide to our customers.
Yeah. So we have, I mean, we're actually overrun the end of our webinar, but definitely reaching the end of the webinar for tonight. So I was really happy to have been here and be able to chat to you all about kind of large language models and fine-tuning. And if you have the need of a platform to help you build out data sets or services around helping create data sets, to be able to fine-tune models on your own data or to be able to do in-depth evaluations, do reach out to us at SuperAnnotate. We're very happy to help you and to chat about different options, or of course to Databricks when it comes to the actual fine-tuning of the models themselves. Well, thank you all very much, and have a great rest of your day or evening or morning, depending on where in the world you are at.